2013, day 1, question 3. Simplify it fully. So we've got 3x to the 4 times 3x to the 4. 4 and 4 is 8. P times P times P equals 64. Now you either know that the answer is 4 or you might just have to try. So for a strategy you could try 2, which clearly would give you 8. You could try 3. 3 times 3 is 9. 9 times 3 is 27. You could try 4. 4 times 4 is 16. We need 16 times 4. 64. So the answer is P is 4. So you either know it or you can use process of trial and error. 2 to the power of r, so we want a whole lot of 2's. See how many we need to multiply to get to 16. 2 times 2 is 4, times 2 is 8, times 2 is 16, so we needed 4 of them. In other words, 2 to the power of 4 is 16. Now just checking negatives. We can't have negative 4 up here. No, because that would give me negative 64. Right. When you're working with powers, it pays to check the negatives as well. Let's see, writing an expression for f. So we want f equals, eventually. Really hard in this form here because f is in the denominator. There are tricks we can use, but it would be really helpful if we could combine these two by adding. Common denominator, u times v. So if we multiply this fraction by v on the denominator to get the uv, we'd have to do the same to the top line. V times u gives me uv, so same to the top line. Now when you have fractions, here's an example, a half is the same as 2/4, just check you agree. As long as you have one fraction equaling another fraction, it's okay to find the reciprocal of both. Reciprocal means turn upside down. And now I hope that you'd be happy to once again put the equals sign in it. So if two fractions are equal, their reciprocals will also be equal. So with this example now, I've got one fraction equals another fraction, and that means their reciprocals will be equal as well. F over 1, which is just f. Right, part 2, an expression for v, so this time we want v equals. It's complicated with the 1 over u here, so if we could get rid of that. Then once again we want to use the reciprocal rule, but to do that I'm going to need to get one fraction on this side. So multiplying by u, multiplying by v. One fraction equals another fraction, their reciprocals will be equal as well. V over 1, which is v. So you could pause that and try it again yourself. Right, if he's late, returning his bike, he's fined $5 for the first hour late. If he's 2 hours late, he's fined twice as much. If he's 3 hours late, he's fined 4 times the original amount. Four times the original fine if he's 3 hours late, and so on. The formula used to calculate the total fine has to pay is t equals 5 times 2 to the h minus 1. This expression here, where the unknown, the variable, is in the power, is called an exponential expression. Not linear, not quadratic, exponential. We're dealing with powers. How many hours late did he return the bike if the fine was 160? So the fine was 160, 2 to the power of h minus 1. That power connection between the 2 and its power is very strong. Stronger, in fact, than the multiplication here. So we can divide both sides by 5. 5 into 160, not easy. 5s into 16, 3 5s are 15, carry the 1, 5s into 10 go 2. You might know that 5 times 30 is 150, which is close to 160. You'd need 2 more lots of 5, wouldn't you, to get the 160. So altogether you'd need 32 lots of 5. Now I can see that this is a power. 2 to the power of something is 32. So as we've already done in the previous question, which relied on powers, we could try multiplying 2, see how many we need to get to 32. 2 2s are 4, times 2 is 8, times 2 is 16, times 2 is 32. So we needed 5. 2 to the power of 5 is 32. Now that means h minus 1 has to be 2 to the power of 5. So if h minus 1 is 5, then that means h would have to be 6. How many hours late did he return the bike? He returned it 6 hours late. And it says you must show use of the formula, so we've done that. Tama's meal costs 1.5 times as much as Rani's. Write an equation for the total cost of the dinner in terms of R. So let's use T for total cost in terms of R, Rani's meal. So the total cost would be the cost of Rani's plus Tama's. Now Tama's was 1.5 times Rani's. So we could write this as T equals R plus 1.5R. There's 1 plus 1.5 would be 2.5 lots of R. Part 2. Cherie joins her friends. Her meal costs $5 more than Rani's. So Rani's plus 5 would be Cherie's meal. Total cost was $75 for all three of them. So R for Rani plus 1.5 R for Tama plus R plus 5 is Cherie's, and altogether comes to 75. That's my equation. We could minus the 5 pretty quickly. And I have 1, 2, 3.5 R equals 70. Now we don't have calculators. 3.5 lots of something, this dollars equals 70. We want 3 lots of a number plus half of the number to equal 70. You might need to do some trial and error. For example, if we tried 10, 20, 30, 35, that's only half of it. So clearly if we tried 20, half of 20 is 10, 20, 40, 60, 70. So in fact R equals $20. Now let's just check what the question wanted. More space. Use algebra to find the cost of Cherie's meal. Hers was $5 more than Rani. So that means Cherie's meal cost $5 more than 20, sorry. 20 plus 5 equals $25. Just reread the question, check that we've got everything we need.